All right, I tried recording during class, and again, the recording did not work. So I'm re-recording. So this may be a faster version from how we went through it in class, but I'll try to fit in everything that we did discuss in class. So looking at the first example, it says to draw the graph of the function f of x equals x squared plus 3 in each of the following viewing rectangles, and then sketch the graph that appears in each viewing rectangle and answer which viewing rectangle gives the best representation of the function. So in looking at each of these viewing windows, how to read these, the first interval, that's the interval for the x values, and then the second interval is the interval for the y values. So on your calculator, let me go back to my home screen. So when you're looking at your calculator, you first want to enter in the function. So go to y equals. Now, if you still have any of your plots turned on from when we went through the scatter plot examples, you'll need to turn those off. So to do that, you can arrow up to whichever plots are turned on, and if you hit enter, it'll uncheck them. So you want it to look like this where none of them are highlighted. Otherwise, you're going to get an error when you try to graph your function. And then if you have anything entered in, like I have a couple functions entered in, just clear those so that it's blank. And then we can type in x squared plus 3. So if you haven't looked at this already, in your second column, your second key down, let me actually show this. So your key right here. So it says xt theta n. If you are in function mode, which your calculator defaults to function mode, when you press that key, it'll show up as an x. So being in different modes, you would get a t, a theta, and n. Theta would be if you were in polar mode, trying to graph polar equations. So we're always going to be in function mode. It'll always show x. And then the x squared button is in the first column, the fifth key down. If you click that, it'll give you the exponent of 2. You do have a caret key underneath the clear key if you need to do any other exponents, and then plus 3. And so then I can just go to, along the top, your second key is window. I can go to window if I manually want to choose what I want my x and y values to be on my graph. So based on this first viewing window in part A, I want the x values to range from -2 to +2. So the x min I would change to -2. So you can either clear it and then type in the number, or if you just type in a new number over it, it'll automatically clear what was there. The negative key is underneath the 3, so it's different from the subtraction key. So -2 for the x min, the minimum x value, and then either click enter or the down arrow, and then +2 for the maximum x value. And then x SCL is the scale for your x-axis. So what do you want it to count by on your x-axis, or show every tick mark? So I'm just going to change that so it just is scaled by 1. And then for the y min, I also want that to be -2, and then the y max to be +2. The y scale is already 1. Underneath y scale, the rest of this, I'll be honest with you, I have never, in any of my years of using a graphing calculator, I've never changed any of this. I probably couldn't even tell you what it does. I would have to look it up. So you don't have to worry about changing anything else when you're in this window screen. And then from here, I can just hit graph. And mine, you might see it as showing this little circle, that yellow circle at the top. That means it's graphing. Some might have 3 dots at the top, kind of like an iPhone when somebody's typing a message. It kind of scrolls through the 3 dots. When that's gone, it means it's done. So you can see I have no graph here, and in class we discussed why that was, and it's because based on the function, this is a parabola that is shifted up 3. So the vertex is at 0, 3, which is not included on our graph. Our highest y value is 2. So this is obviously not a good viewing window for this function. We can't even see anything. So in class, I had everybody go through and graph using the other 3 viewing windows and then choose which one they thought was best. So you could pause right now and go through and do that, and you should see that the best viewing window would be viewing window C. D is also not a terrible viewing window. It's just zoomed out farther than it needs to be, so C is really the better one. When we got to example 2, it says determine an appropriate viewing window for the function f of x equals the square root of 8 minus 2x squared, and use it to graph f and sketch the graph below. And then I did give a hint. For some functions, if you know the domain of the function, it could help you in finding an appropriate viewing window. There were questions in class based on these viewing windows. How do you know which one to use? It is a lot of just guess and check. And there's ways to get the best viewing window. So sometimes, at least for the x scale, knowing the domain can be helpful. So with this function, we found the domain. So for a square root function, what's underneath the square root needs to be greater than or equal to 0. So 8 minus 2x squared needs to be greater than or equal to 0. Solve for x. So subtract 8 from each side. Divide each side by -2, which is going to flip your inequality. So x squared is less than or equal to 4. Take the square root of each side. And remember, with an inequality, we then write that as the absolute value of x is less than or equal to the square root of 4, which is 2. And that means, so x is a number that has a distance away from 0 that's less than or equal to 2. So this is really the x values between -2 and +2. Or in interval notation, we could write it this way. So based on that, we could get a good x scale, x min and max, for this particular function. So then what I had students do, let's go to y equals, and let me actually, I'm just going to cover up my work here, I guess, so I can see the function. Let me type in the function, so I'm going to clear the one I had before. The square root is if you hit second and then x squared, and then 8 minus 2x squared. All right, so I typically said anytime I'm graphing a function, my first step is always to go to the standard viewing window if I'm personally trying to find a good viewing window. And the standard viewing window is if along your top 5 keys, the middle one is zoom. If you go to zoom, and then zoom option 6 is zoom standard. And I'm going to come back to the screen. If I go to window, zoom standard gives you this window. The x scale is from -10 to 10, so is the y scale, and then they're actually scaled by ones. So that's the standard viewing window. That's usually my go-to, at least to start. It clears out the window that was in there previously. This actually isn't a terrible viewing window for this function. This is actually okay. But based on the domain that we found, -2 to 2, and I can kind of see on my graph that that's where the graph starts and ends. That gives me an idea of how I can zoom in on my x-axis. And then I could also even see from here, I don't have any negative y values. And then based on my tick marks here, I can see the maximum is kind of between -2 and 3 for the y value. So I could even scale down my y-axis. So if I go to window, I can change my x min and max. I usually do at least one out from what the domain would actually be, so I might do this from -3 to 3. I'll still scale by ones. And then my y min, I saw the lowest y value was 0, so I might do -1, and then 5 for a maximum, since the maximum was in between 2 and 3, so just a little ways out from the max. And now if I hit graph again, it is zoomed in more. So that would be, I guess, a more zoomed in, clearer picture. I also talked about how it doesn't quite touch the x-axis on my graph, but I know that it should, because when I substitute in -2 and 2, the y value is 0, so those values do exist. So it should touch, even though the graph is showing it doesn't. So you have to be smarter than your calculator as well. there's another option to zoom in, which I'll actually show. There's zoom in and zoom out features. I'll show that in example 3. So for example 3, now this function, we couldn't use the domain to help us because the domain is all real numbers, or negative to positive infinity. So I'm just going to go to y equals and clear this and type in x to the 3rd power. So I need my caret key, which again is the key underneath clear. And then 3, and then I need to use the right arrow to get out of the exponent. And then, what was it? Minus 150x. Okay, and I'm going to go to my standard viewing window first. So zoom option 6. And, okay, so I just saw it, and you can kind of see it on mine, that this blue curve kind of came down along the y-axis. So we discussed in class what this graph should look like. It's a cubic function, so it should have this type of shape, or at the very least, if it doesn't have a local max and a local min, it at the very least should look like this. And I know it's increasing because the value in front of x cubed is positive. So I'm not seeing that based on this viewing window. It's not the greatest. So one thing I can do, this means I'm zoomed in too far. I want to zoom out. So an option I have is to do zoom, and then 2 and 3 are zooming in and zooming out. So if I hit option 3 to zoom out, I have a cursor which defaults at 0, 0. It'll show you on the bottom what x and y values the cursor's at. And wherever that cursor is, if you move it around with your up, down, left, and right arrows, wherever that cursor ends up, that's going to be where the center of your screen is when it either zooms in or zooms out. So I still want the origin to be the center of my screen. So I'm just going to leave it there and click enter. And now it zoomed out. Now this still isn't a great graph, but I at least saw when it graphed is that this part was increasing and then this part came back down for decreasing, and this part went back up. So I know I'm on the right track. I need to zoom out more. The reason my x and y axis look like this is if I go to window, my scale is still set to 1. So when my x and y values are set from -40 to 40, there's 80 tick marks on my screen for both axes. So I can change that if I change the scale. I could change it to maybe count by tens, and then it won't look like that. But looking back at the graph, I'll just go back to this to explain so you can see my x and y axes look better. I don't need to change my x-axis at all. If anything, I could really move in. I'm seeing extra that I don't need to see. But if I leave it at -40 to 40, that's what it defaulted to, that's okay. I still need to increase my Y scale. So I'm going to go to window. I'm going to leave the x min and max as they are. If anything, I could make them smaller. I could do -30 to 30 or -20 to 20. But my Y min and max I want to make higher and lower so that I'm seeing more of the y-axis. So I might try -100 to 100. I'll still count by tens and then graph it and see where we're at. Okay, so a little better, but still not great. So I still need to zoom out, get larger and smaller y values for the min and the max. So I'm going to go back to window. And now maybe I'll try, and this is where it's guess and check. It's playing around with it. So maybe -500 to 500. And then maybe I'll count by hundreds. Hit graph and see what happens. Okay, we're on the right track. It looks like we're just missing the top of that hill and the bottom of that valley. So I'm going to go back to window, and where we ended up in class is we ended up at -1,000 and 1,000. And maybe you don't need to zoom out that far. I'll keep my scale at 100. But this did give us a better window. Okay, so that's what you want to see when you're graphing a cubic function. It's good to know the window for how far out we're zoomed, but that's what you want to see, that local maximum and local minimum. One other thing I did talk about with this example is there is a zoom option that I want you to be cautious of. So if you go to zoom, it's option 0, and it's called zoom fit. So I'm just going to hit that. Zoom fit tries to find the best graph. I would say, I don't know, 95% of the time, it does not find the best graph. The graph it finds is not great. So this is the graph of the same function, but this is using zoom fit. Hopefully you agree with me that this graph is not as good as the previous one. And if I go to window, I can see what it changed the window to. Look at the Wyman and Max and how zoomed out that is. So like I said, 95% of the time, zoom fit does not give you a good viewing window. If you want to use it as a starting point and then change your window from there, that's fine. But do not always just trust and go off of the window that it originally gives you when you use zoom fit. Be cautious with that. All right, and then example 4. So with this graph, I'm going to go back to y equals and type this in. Make sure when you type it in, there isn't a fraction key. You have to hit the division sign. And then make sure you include parentheses around your denominator when you type it in. So I'm going to type in 1 divided by, and then your parentheses keys are the keys above the 8 and the 9. So I need left parenthesis 1 minus x, right parenthesis, and then I'm going to go back to the standard viewing window, so I want zoom and then option 6. Again, that's my default because it clears out whatever window I used previously. If you just hit graph, it's going to use the window you had in there the last time you graphed something. So I see these curves, and then now your calculator might look different. If yours, what sometimes happens is it will connect these. So I'm not sure if that's happening with yours right now. I was asking that in class. But if it connects these, I just want you to realize this is what the graph should look like, where they're not connected. At x equals 1, there is a vertical asymptote. So you can see from the domain based on the denominator, x cannot equal 1. So if yours is connecting these, that's just another instance where you need to be smarter than your calculator and realize they shouldn't be connected. Your calculator is just taking all of these pixels and then connecting them to make a graph, and so on some calculators it will connect them, even though it shouldn't. So that was just more of realizing when that happens that it's not actually part of the graph, there's an asymptote there. We did skip over example 5. I briefly explained what it was asking. It said graph the function y equals x cubed plus cx for various values of the number c. How does the graph change when c is changed? So I said, let's say c was 1. Then the function would be y equals x cubed plus x. And then if c was 2, it would be y equals x cubed plus 2x. I could go in the other direction, maybe c is negative 1. Y equals x cubed minus x. I skipped over c equals 0. I could do that as well. And I said you could graph these all on the same screen. Maybe this is y1, this is y2, this is y3. And all you're doing is you're seeing how changing the value of c changes what the graph looks like. So this is a family of functions. They share common characteristics, but changing the value of c will change the graph, what's happening. So there is some practice like this in the assignment, but I more so just outlined what that problem was asking. We didn't go through it in class. And then moving on to example 6, this one I wanted to make sure we did go through, which is we skipped example 5. So it says find the solution of the equation cosine of x equals x correct to 2 decimal places. Now it says 2. Typically in AP Calc we do 3. This one does specify 2, so we'll just do 2 decimal places. But I pointed out with this equation, sometimes you're going to get equations that are either very difficult to solve by hand or algebraically, or even maybe impossible to solve algebraically, impossible to solve without some sort of computer software to help you. Your graphing calculator can help you in the sense that we can use the graph of functions to solve this equation. So throughout this year, if that comes up, just know that's an option. So what we can do is we can graph each side of our equation. I can graph y equals cosine of x, and maybe I'll graph that in y1, and then I can graph y equals x, and I'll graph that in y2. So I'm graphing both on the same screen. So I'm going to go back to my y equals, clear my previous graph. You should see sine, cosine, and tangent keys on your calculator. So cosine of x, I'll put in y1, and then just x, y equals x into y2. And before I graph this, I know I said I usually do zoom 6 for zoom standard. But when I graph trig functions, first of all, you need to make sure your calculator is in radian mode, otherwise you will not get the right graph. So right next to second, the mode key, just make sure that radian is highlighted. If degree is highlighted, go down to radian and click enter to highlight it. So now I'll go back to y equals. Once you're in radian mode, when you go to zoom, anytime I graph a trig function, there's a zoom trig feature which gives really good viewing windows for trig functions. So I'm going to do zoom 7 because it does have the markings that every pi has, which is why this window is really nice. So there's cosine of x, and now it's graphing y equals x. So the solution to this equation is where those two curves intersect. So there's an intersection point here. Now, there is a trace feature on your calculator. If you just hit trace, it's the fourth key along the top. This will give you a cursor, and you can move it along. It'll tell you in the top left which curve it's on. And if you use the left and right arrows, you can move it along a curve. If you want to switch which curve it's on, say I want it to be on the line, I can hit the up or down arrow to switch the curve. All right, sorry for the pause, somebody was at the door. So you can hit the up or down arrow to switch which curves it's on, and notice at the top left it'll show you what curve it's on. And then if I use the left and right arrows again, I can move it along the line. So you could move it so that it's really close to that intersection point, and it'll tell you the x and y value where your cursor is. Now that isn't the best way to find the intersection point because this is moving along with pixels, so depending on how far apart the pixels are, you might not get exactly that intersection point. So if you actually hit second trace, so it says calc above trace, that's the calculate menu, so second trace, you can find, or your calculator can find the intersection. So if I hit option 5, this is how you use this feature. It'll show you which curve it's on. So right now it's on my y equals cosine of x, and it'll say first curve. All you have to do is use your left and your right arrows to, I typically move my cursor so that it's either close to the intersection point or try to get it on the intersection point. It doesn't have to be exactly on it, it just has to be close to it. And click enter. And then second curve, and typically your cursor is still really close to that intersection point, so I'm not even going to move mine. And it'll show you now it's on the line, click enter. And then guess, this is just saying to move the cursor, guess where it is. I do nothing for this, I just hit enter a third time. And then it'll give you the best approximation the calculator can for the intersection point, the x and the y value. So we only need the x value for the solution. So it's at approximately to 2 decimal places, 0.74. And that would be the solution to that equation. So see me if you have questions with your calculators.